Today's lesson is about finding the missing quotient in a division problem. This opener is posted in the virtual classroom. If you would go back to the virtual classroom and click on the lesson opener and watch it, and then come back and watch the video lesson if you haven't done that already. So let's explore how we can think about a problem as a division or multiplication problem. A pet store has 18 hamsters. The shop owner wants to put 3 hamsters in each cage. How many cages does the shop owner need for all of the hamsters? We've been looking at word problems throughout the school year, and what we've done is we've talked about finding the important parts to a word problem. And so I'm going to go back and reread each sentence and pick out the important parts. A pet store has 18 hamsters. That is important. That is our total. The shop owner wants to put 3 hamsters in each cage. So that's the amount in each group. How many cages? We got to figure out how many groups does the shop owner need for all the hamsters. So a pet store has 18 hamsters. That's important. The shop owner wants to put 3 hamsters in each cage. That's important. That's how many is in each group. So what we don't know, what we're not given in this word problem, is how many cages does the shop owner need for all of the hamsters. It says to draw a model using equal groups or an array to show the problem. So in class, I was letting the students decide which one of those they wanted to use. If you'll pause the video and see if you can figure this out with a scratch piece of paper, notebook paper, and then come check back with me to see if you got your answer. So if we do equal groups, we're putting, it says 3 hamsters in each cage. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's my total. And I can see modeling it out that way. 18 hamsters put into 3 groups, 3 equal groups of 3, excuse me, will give me 6 groups. If I do an array, like you saw on the Learn Zillion video, we can count down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And when we do that, we can see there's 6 in each group. So now we're going to take each one of these and write this word problem as a division equation, a multiplication equation, and then show how we could write the answer. For a division equation, I reminded students about the parts of a division sentence, the chart that we did, and I'll just quickly put it down here. So the first number in a division sentence is your total, and this chart should be in your math folder in the multiplication sheet protector, excuse me. And then the second number is the number of groups. Is usually what we say. And then the last number, your quotient, is most of the time telling you how many in each group. And we went through a couple of slides ago and looked at the important parts. We know the total. We said that 18 was our total. So we're going to say 18 divided by, we don't know our number of groups. That's what we're trying to figure out. Cages can represent groups. So we're going to, it says use the box for the unknown. We're going to say 18 divided by some number will give us 3. That's how many is in each group. If you looked at it and said you were going to put 18 divided by 3 equals some number, that's okay too. You can flip-flop these two. Just as long as the most important part is that you put the total at the beginning of the sentence. You started off with that. Write a multiplication equation for the problem. If I have 3 hamsters being put into groups, 3 groups of, I wasn't given that part in my word problem, will give me 18 in all. I have 18 total. Or you could say you don't know the number of groups, but you're going to put 3 in each group, and that equals 18. Well, we know from modeling it out on the screen before, both with equal groups and an array, that the number of cages that the shop owner needs is 6. So how we're going to write that is to say the box equals 6. Box equals 6. We're not going to put the number in the box because that can be hard to look at sometimes, and other times the box is actually too small to write in. It's just substituting the box for the number that you're not given in the word problem. So 3 strategies we just used. We drew a model, either using equal groups or an array. We took the word problem and we were able to write a division equation from it with a part that was missing. And then we also wrote a multiplication equation with a part that was missing, not given to us in a word problem. And let's try that on this one. So Manuel has 42 quarters. He puts them into 7 piles. He puts the same number of quarters in each pile. How many quarters are in each pile? I'm going to go back and reread that word problem a second time and highlight that important information. What am I given that I need to use? Manuel has 42 quarters. That's important. That's my total again. He puts them into 7 piles. Piles are like groups. He puts the same number, that's important, of quarters in each pile. How many quarters are in each pile? So I'm going to figure out how many go in each pile or group. If you will pause the video and see if you can write a division equation for the problem using a box for the part that you don't know or not given in the word problem. Also go ahead and try to write a multiplication equation using a box for the part that you're not given. And then the last thing, how many quarters are in each pile? You'll need to use an array or equal groups to figure that out. So pause the video and work out parts 6, 7, and 8, and then check back with me for your answer. Remember, division sentences need to start with the total. 42 divided by 7, that's my number of groups. That's what I'm trying to figure out. The unknown is the part I'm being asked to solve for. So that's 42 divided by 7 equals box. A multiplication equation, I would say 7 times some number gives me 42. If I make 7 piles or 7 groups, and I'm going to count out 42, I don't know how many is going to go in each group yet. Also, remember you can write it the other way if that's what you have put down. So how many quarters are in each pile? If we count it out, a lot of students in class today were drawing the 7 groups and counting out the 42. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42. So we can see that how many quarters are in each pile. 6 quarters are going to be in each pile. So we would say the unknown equals 6. Box equals 6. Let's go back and look at our answer to problem 6. Explain how you knew what equation to write. And I think we went ahead and talked about that as I was building each sentence. The 42 is your total. It has to go at the beginning of a division sentence. And it has to go at the end of a multiplication sentence. Then one of the parts that you have would need to go next. If you know your number of groups, you just try to be consistent and say that would go next. And then you're solving for what you don't know, that unknown box. And we drew that out in an array this time. Excuse me, equal groups. You could have done it in an array if that's the model that the strategy you like the best, that works best for you. So Justin knows that 8 times 7 equals 56. What related division equation can he write? If you will pause the video and try to figure that out, you're given each part of the fact family, and I showed that in a fact family triangle right here. Yeah, I think y'all use triangles at the primary school for addition and subtraction fact families. I think I've shown it to you a time or two for multiplication and division. So your total goes at the top of the triangle, and then you can just read around the triangle. You could say 56 divided by 8 equals 7, or 56 divided by 7 equals 8. Or if you read it as a multiplication problem, you would say 7 times 8 equals 56, or 8 times 7 equals 56. So pause and write that a division sentence down and check back with me. I told you the answer verbally, so you could say 56 divided by 7 equals 8, because that's, if you read a multiplication sentence backwards, it becomes a division sentence. Or you might have seen, I need to put 56 first, but you wanted to put the 8 and then the 7. That's okay. And since we're talking fact families, I've got the students to, in class, write down the other missing multiplication fact. We had 8 times 7 equals 56, and the other way we could write it is 7 times 8 equals 56. Even though you may not have that memorized, like I said, once you're given all parts or pieces of the fact family, you can just swap them around, change them up, and get the multiplication and division sentences that those numbers make up. So here are some try it problems. Students worked these out in class and we went over them. I pointed out that number 11 has a threes fact in it, and we memorized our threes fact, so we really shouldn't have to draw this out with an array or equal groups, because you memorize 3 times some number equals 24. So if you had this piece of paper in front of you, you could just write that down. If you, whatever work you're doing on, if you will just practice writing box equals and put that answer down on a piece of paper, these are those tiny boxes that you really can't write in if you'll just put the answer out beside the box. And then I told students number 12, you haven't memorized a nines fact yet that equals 54. You've memorized 2 times 9, but that equals 18, so that can't help you. You've memorized 3 times 9 equals 27, but that's not what we're looking for. And you also memorized 4 times 9 equals 36. And this week you're practicing your fives fact. 5 times 9 equals 45. That's not it. So you could either draw it out, make 9 groups, and share out 54, or you could, remember multiplication is like repeated addition. You could add on another 9 and see what you come up with, and that would be what 6 times 9 is. So just pause the video and come up with the answer to the unknown, what the box equals in each of these problems, and check back with me. So you should know that 3 times 8 equals 24, so box equals 8 in this problem. And if you did go on and add on 45 plus 9, one student in class did that today, and he found out that that's 54, which is what you're looking for. So that's adding 9 to this group, and that's repeatedly adding 9 6 times. Or some students drew that out, and they made 9 groups, and they counted out 54. If you're don't have the missing part, this is a strategy. It might take you a little while to get to it, but at least you will get to the answer until we get all these facts memorized. So I'm going to count out 54, share it equally among the 9 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54. And yes, that's proving that 9 groups of 6 makes 54. Kayla has 8 markers in all. She sorted all of her markers and put them into an unknown number of boxes. Kayla put 2 markers in each box. The story can be written as this number sentence. 8 divided by some number, that's a question mark, same as if we put it a box there. 8 divided by some number equals 2. Well, you know your 2's facts, so you could then ask yourself 2 times what number equals 8. And what would fill in that box? A, B, C, or D? The correct answer is D. 2 times 4 equals 8. What unknown number makes this equation below true? Some number equals 45 divided by 5. And that's kind of a backwards way of looking at it, but it's okay to write it that way. I ask students a lot of times just to rewrite it. 45 divided by 5 is some number. And the multiplication fact that goes with that would be 5 times what number equals 45? Is it A, B, C, or D? We're learning our 5's facts this week. And yes, the correct answer is D, 9. 5 times 9 is 45. Here's our quick check. There are 9 trees in Jeffrey's yard. There are an unknown number of squirrels in each tree and 54 squirrels in all. This story can be written as the number sentence. 9 times what number equals 54? Use the number sentence to find how many squirrels are in each tree. This looks like something we drew out in a picture on a couple of slides ago. Is 9 times 45 54? 9 times 54 54? 9 times 6 54? Or 9 times 9 54? And the correct answer is C, 6, because we actually drew this out a few slides ago, right here. Sometimes the work we do on one problem can help us answer another one. And that is the quick check for today. It's today's lesson. If you will find the math practice pages and complete those, please let me know if you have any questions.